Hello, I'm Mišof and I'm going to present problem D, debugging. So, in this problem we have a situation everybody experiences quite often. We have a code, the code consists of n lines, we already ran it once and we discovered that it's buggy and it actually crashes. So, what can we do now? The only debugging technique that is available is adding printf statements. So we can add printf statements somewhere into the code. And then when we run the code, we will see some of these printfs. For instance, if we add them here, here, and here, we run the code and we see this output, we see this, but we don't see this one. Then we know that the bug has to be in this part of the program. We would like to discover the bug as quickly as possible. And now there are two constants that interest us. One constant is the time t1 necessary to insert the printf statement. And the other constant is a constant t2, the running time of the program from the beginning until the moment when it crashes. Here we assume that adding the printf statements does not influence the running time. So now we are given the number n, the number of lines, and these two times, t1 and t2, and we have to compute the optimal way of doing this debugging, the shortest worst case time in which we can find the bug. So let's see this for an example. So suppose we are going to add exactly 3 printf statements and then run the code. So what can happen? We can get one of 4 different results. We can discover that the bug is here, the bug is there, the bug is here, or the bug is there. We still have the same constants t1 and t2. The only thing that matters is, again, we reduce the number of lines from n to this one, or this one, or this one, or this one. And if we are looking for the worst case, so the thing that matters most is the length of the longest segment. And if we want the optimal solution, we want this longest segment to be as short as possible. So if we decide that we want exactly 3 printf statements, the optimal way to place them is the first fourth, the middle, the 3/4, and that's it. So the longest part will always be n divided by the number of printf statements plus 1 and round it to the ceiling. So now with this knowledge we could write a dynamic programming solution in quadratic time for each n, starting from 1 until up to the value given in the input. Try all possible number of printfs. Each of them will give you a single recursive call and a smaller problem. So this is almost the complete solution, because the only thing that was left to realize was if you don't implement this as the iterative version of the dynamic programming, but if you implement it as a memorization, so you just start with a recursive call, solve this for the value n, and only evaluate those states you need, it will actually run in n log n time. And this is because the only visited states will be the states of this form, n divided by some value I. So if you start with n, your first recursive call will be n half, then it will be n divided by 3, n divided by 4, and so on. And if these are the only visited states, then you do NWERC for the first one, n divided by 2 for the second state, n divided by 3 for the third largest state, and this work sums up to n times log n. And there are actually some other even faster solutions. For instance, instead of trying all of the n possible numbers of printfs, it is enough to try square root of n, and there are also other possible ways to approach this problem, but already this straightforward memorization is fast enough. And that's it.